So this is the calculations check test based on molar volume and also on excess. So apologies firstly for the shadow here, that's just the camera taking this, casting a shadow from the light above. And also apologies, this is the best resolution I've been able to get it into. I will work on my cameras. So, question 1. The equation for the complete combustion of propane is C3H8 gaseous plus 5O2 gaseous plus 3CO2 gaseous plus 4H2O liquid. So first thing, when I read the question, 30 centimetres cubed of propane is mixed with 200 centimetres cubed of oxygen. The mixture ignited. What is the volume of the resulting gas mixture? First thing I'm doing is I am getting rid of water because it is not a gas. So I'm only dealing with those three. And the ratio of them is 1 to 5 and it goes to 3. Okay? Now, I'm looking for resulting gas mixture, so that means I'm looking for any excess reactant left over plus any product produced. And the information in the question told me I had 30 of this and 200 of this. Okay, that's what I have. Now I'm assuming if I have this, then what I would need is 150 of this because it's 1 to 5, so I multiply this by 5. I've got more of the oxygen than I need, so this one is in excess. So I'm going to base my products, what I produce, on my limiting reagent. So that's limiting, that's excess. Then I'm going to look at what I produce. If I've got 30 of that and the ratio is 1 to 3, that means I'm going to produce 90 of that. And then all that's left is what's left over. Well, I've got nothing left over because I'll have used all my limiting reagent. I have 50 left over from this, and I've produced 90, so that gives me 140. That's one of my answers, answer C. Okay, next question. Calcium carbonate reacts with nitric acid as follows. So calcium carbonate solid plus 2 nitric acid aqueous goes to calcium nitrate aqueous plus water liquid plus carbon dioxide gaseous. I'm told 0.05 moles of calcium carbonate was added to a solution containing 0.08 moles of nitric acid. Right, so I've got my moles of this and I've got my moles of this. So immediately I'm thinking excess. Which of the following statements is true? So first one relates to carbon dioxide, so I need to work out which one is limiting in order to predict how much carbon dioxide is produced. Calcium nitrate is produced. Again, I'm going to need to work out which one's limiting to do that. Calcium carbonate is in excess by 0.01 moles. Okay, so I'd have to prove that that one's in excess first, and then by how much. And finally, nitric acid is in excess, and by that much. So firstly, I need to work out which one's in excess. Now my ratio is 1 to 2. First thing I always do. And I've been told I've got 0.05 moles of this, and I've got 0.08 moles of this. Now that's what I have. Now I'm going to take this one. If I have that, then I'm going to need 0.10 moles of that. And that would make this one in, that I have less than I need, so that one is limiting. So I can immediately rule out that's limiting. Now before I do anything else, if that one's limiting, that's excess. So I need to work out how much in excess I have. So what I'm going to do is look at my ratio again. It's 1 to 2. I know I have 0.05 of this, and I have 0.08 of this. But instead of saying if I have this, how much of this I'm going to have, I'm going to say if I've got this, how much of this do I need? So if I've got 0.08 and the ratio is 2 to 1, that's what I have. What I need is 0.04. Because I have more than I need, that one's definitely in excess. And it's in excess if I subtract that by 0.01. Calcium carbonate is in excess by 0.01 is one of my answers. I know it's true. If you want to, you could go on to look at these two, but you'll find that they are false. A limiting reagent is this one, which is 0.08 moles. And in each case, it's a 2 to 1 ratio. So I'm going to make 0.04 moles of carbon dioxide, which doesn't match here. And I'm going to make 0.04 moles of calcium nitrate, which doesn't match here. So C is definitely correct. Next, we've got the two other questions. So question 1, chlorine gas can be produced by heating calcium hypochlorite, that's a formula, in dilute hydrochloric acid. And I've got an equation, and calculate the mass of calcium hypochlorite that would be needed to produce 0.096 litres of chlorine gas. Okay, so I've got information about the product and I'm being asked about a reactant. This is a simple mole calculation. So this is my ratio. It's 1 for the calcium hypochlorite. It is 2 for the chlorine. Next thing, I write down what I know. So I'm being asked about the mass, which is G, and then, so I have to work out my GFM in order to do that. Now it's calcium, so it's calcium times 1, oxygen times 2, chlorine times 2. Now calcium is 40.1, oxygen is 16 times 2, and chlorine is 35.5. So when I do that on my calculator, so that's 40.1 plus 16 times 2 plus 35.5 times 2, that gives me 143.1. Okay, that's all the information I know about that. For chlorine, I know molar volume is 24, and I know that my volume was 0.096. Now the number of moles is volume divided by molar volume. So 0.096 divided by 24, which equals 0.004 moles. That's going to get you one of the 2 marks. Calculating that is going to give you one of the 2 marks. Now I'm going to look at my ratio. It's 2 to 1, so if I've got 0.04, that means I'm going to need 0.02 moles, 0.002 moles of that. So N equals 0.002. And mass equals N times GFM, which is going to be 0.02 multiplied by 143.1, which is 0.286 grams, and that's just been rounded up to 3 decimal places. Okay, that's that question. Now, final question. Copper oxide reacts with sulfuric acid as follows, and we've got an equation. Everything's in a 1 to 1 to 1 ratio, and it's balanced. We're told that 1.6 grams of copper oxide is added to a solution of 50 centimeters cubed of 0.25 moles of sulfuric acid. Calculate the mass of water produced. So this is my final thing, but firstly, I've been given a mass of this, and I've been given a concentration and volume of this. So I'm going to be able to work out the moles of both reactants, so this is excess. So I'm going to start just by looking at my reactants. If I just look at my reactants, my ratio is 1 to 1. For this one, I've been given mass equals 1.6 grams, and I can work out a GFM. It's 1 copper, which is 63.5, plus oxygen, which is 16, so that's 79.5. My H2SO4, I've got a volume, which I need to turn into litres, so that's 0.05 litres, and a concentration of 0.25, which is from here. N equals M over GFM. So that's 1.6 divided by 79.5, which is 0.0201 to 3 significant figures there. And N equals CV, C times V, which equals 0.05 multiplied by 0.25, which is 0.0125. That's a 1-to-1 ratio, so all we need to do to work out which one's excess is see which one we've got more of. That one we've got more of, so that is excess. This makes this one my limiting reagent, and I always use my limiting reagent to predict my product. So now I need to look at water. This is my sulfuric acid, the limiting reagent, and the ratio is 1 to 1. So if I have 0.0125 here, I'm going to produce 0.0125 moles of water. Now the GFM of water is 18, and mass equals N times GFM, which is 0.0125 multiplied by 18, which equals 0.225 grams of water. So there, in 12 minutes, I've shown you and worked through all the examples from the check test. Now remember, in an exam, you would have about 18 minutes to do those questions. So it is about developing the speed and developing the technique. I will obviously create more videos for each check test that we do.